Good morning, ladies and gentlemen. As Pia said, my name is Janne Poranen, and I will give you a short talk this morning about the piloting facilities, what we have, and opportunities, what we have at VTT. And there is also something about the foam forming, what is on the title, but actually here is the outline of my presentation today. So first I will introduce you what our SUORA research environment is and what you can do with SUORA. Then I have a couple of realistic cases what we have been working at in SUORA scale. And the last example, high fill content paper, is actually coming from our testa concept. I will give you a short introduction what we mean about the testa concept. And then finally, I will tell you about our latest development related to the foam forming technology. So SUORA is the research environment for fiber processes. I would say that it's more like a research and innovation platform where you can do research related to different kind of fiber processes. The scale of SUORA is somewhere between the laboratory scale environments and with the industrial pilot paper or board machines. So it means that it should be, and I would say that it is quite flexible, it is public, and you can do quite cost-effective research when using SUORA research environment. And always someone is asking that what is the cost estimate if you would like to do research on that scale, and always the answer is the same, so it's depending on the cases. But the average, I would say, is somewhere between 30,000 euros up to 50,000-60,000 euros per week. And it's including all the laboratory work and then the research resources what are needed depending on the cases. Here is a couple of images about the SUORA. So it looks like an industrial scale pilot paper or board machine, but anyway it is a little bit smaller, it is flexible. We can set up the concept at SUORA for the purposes what is needed. For example, the forming section can quite easily used in one wire form or 4-linear mode or the gap mode, and then also the short circulation system and the process can be used in different ways, so that if there is need to do this kind of experiments that you would like to run your furnace only once through the whole process, it's possible. And then if, for example, the raw material, the amount of the raw material is the issue, we can use quite small volumes, even though that the scale of the research environment is quite realistic one. And then, of course, we have quite big tank volumes. At the moment, we have 3 100 cubic meter tanks and then couple of tanks with 50 cubic meters, so it's possible to do also multi-component trials if needed. And as you can see about the technical specifications, it is I would say the latest technology, and we can run it up to 2,500 meters per minute. So that is not a, let's say, bottleneck on that environment. The first example what we have been working at is coming, and it's related to the energy consumption on the paper or board making, and especially on the forming section. As we know, the forming section is using quite a lot of energy in the whole process. And in that special case, which was actually done already 2009 together with the Tamfeld Corporation, we were looking at what you can do just by using different kind of forming fabrics. So we were only playing with the design of the forming fabric, and then we were able to measure what is the friction force between the vacuum box and the forming fabric, and also the total power needed on the forming section. And it was quite a surprising result that only by using different kind of forming fabrics, the use of energy total in the forming section can be reduced more than 10%. And then if you think about that, you start to play with the other optimization issues also, like a chemical concept, furnace concept, or the technology what you are using. We believe that there is still a huge potential about saving energy in today's processes. And Tamfeld made already first installation in the paper mills at the late 2009. The next case is related to the chemical spraying technique. Basically, there is nothing new about the spraying technology, but now what we did, and actually this was done last year at VTT, we were spraying different kind of polymers onto the wet web between the forming section and the press section. And I'm not the expert, but I know a little bit about that. There is this kind of idea behind that when you are using spraying the chemicals on the wet web surface, there is different kind of phenomena and interactions how the chemicals are behaving, and we were looking at what kind of effects can you see by using this kind of let's say technology to use commercial polymers. Okay, here is maybe a little bit too much text, but the main finding was that there was nothing like let's say bad effects, for example, to the dryness of the wet web after forming or press section. There was no effects on the bulk of the final product. But what we saw that there is a huge potential how you can increase the wet strength of the wet web by using this kind of polymers and by this spraying technology. In the case of guar-gum polymer, it was seen that compared to the cationic starch, which is used normally, you need starch about 5 times more than the guar-gum polymer to get the same tensile strength on the wet web in the same dryness level, which is seen on the right down corner. And there is going to be a presentation on the PaperCon conference actually next week, and maybe Mr. Christian Salminen and also Dr. Elias Retulainen, who is joining us today also, they are the experts on that field. So if you have any further questions and would like to learn more about that one, after next week there is going to be a public paper about on that issue. Okay, the third example is done under the INT TESTA or the TESTA concept. This INT is coming from the word international. So we had this kind of TESTA concept already 3 years back, but then it was more or less like a Finnish-based concept. But the main idea is that we are trying and we would like to get small companies, large companies, and research organizations work together, because we believe that there is a lot of new innovations around, and if we can put those together and work together in some public, let's say, platform, there might be a big opportunity also for the large companies and also for the research organizations, and especially for the small and medium-sized enterprises. So we had this kind of project ongoing, and it was publicly funded, so it is totally public. And the only costs for the SMEs was that they had to use their own time to join and work together with us and to work together with other SMEs and big companies. And the results has been very nice, and all the participants has been quite happy, I would say. And of course, in some cases, it's hard to see that what is the real potential. But anyway, we believe that we should continue this concept. And at the moment, actually, we are planning the continuation for this test concept. And if anyone from the companies is interested about this concept and would like to join, would like to come into the VTT and work together with us and together with other companies, you can contact me or someone else from VTT. Okay, here is the quite a new result which was done in Intesta trial week. The goal was to look at how much we can increase the filler content on SC paper. Omia was very active on that trial week, and Mr. Timi Hyppänen is here today also, and you can ask him if need any further information about that case. But what we did, we were trying to increase the filler content from 30% up to the 50%, and it was quite successful. We were able to run the machine. It was stable. There was nothing like runnability issues. And even though that the filler content was increased, also the retention was on the very good level and actually a little bit increased. There is one example on the right down corner where you can see that when the filler content is increased, the ISO brightness is also increased on the final product, which tells that there is some filler increase also on the paper, and the retention is quite good. So of course we all can understand that if you can actually do this in the real life, there is a huge potential in many processes what we are using today. Then I have 3 minutes left, and as the title was also mentioned, I try to tell you something about the foam forming. We have been working on the foam forming technology on the forest cluster programs a couple of years now. We have seen that there is a huge potential on that technology, and maybe now we are on that time that forest industry is also looking something totally new, and this kind of like a step like changes about the processes and how you can get the real benefit out of your production. Here is one example, and it's related to the bulk and how you can play with the bulk when using foam forming technology. So you can see that you can increase bulk quite a bit with this technology, and it's not possible to go with the water-laid processes for these numbers. And of course then there is those questions that how you can keep the strength at the same time, but we believe and there is already some results that it's also possible. So what we are doing at the moment, we started up new quite a big €2 million project to upscale this foam forming technology into the SUORA scale. It was started at the beginning of this year. It will continue at the end of 2013. It is the public funded project. There is a strong industrial involvement already, and the target is very, I would say, very, very high, because our aim is that already this year we are able to run our SUORA environment by using foam forming technology. Thank you very much, and if you have any questions related to these issues, I can help you or someone else from VTT. Thank you very much.